Welcome to this snapshot video from research performed at the UK Solicitor NMR facility. My name is Frederic Blanc from the University of Liverpool, and today I'd like to show you how we have used MassNMR to track structural defects. So we've been interested in lanthanum niobate for a number of years here. The structure is given here. This is an oxide that has layers of isolated niobium tetrahedral. Announcement in oxide-ion conductivity is observed when tungsten 6+ dops on the niobium 5+ site, and this is associated with the creation of interstitial oxygen ion. This must be associated as well with a change in niobium coordination number, which we've decided to track with niobium 93 NMR. So niobium 93 may be seen as an exotic nucleus. It has a spin quantum number of 9.5 and is very sensitive with a natural abundance of 100% and a geometric ratio just below the one of carbon. However, resolution is often a challenge, mostly driven by the fact that niobium has a quadrupolar moment that is very large. So we've exploited the very high field of the 850 MHz facility to narrow down the second order quadrupolar bonding associated with this quadrupolar nuclei on the magic angle spinning, and we've carried out experiment on the very fast MIS using the facility 1 mm Joule probe. This is the spectrum of lanthanum niobate recorded under a triple quantum Z filter MIS sequence. It shows a single resonance that has an anisotropic chemical shift on the order of -840 ppm, and that fits exactly in the region where one would observe and expect to observe 4-fold coordinated niobium in full agreement with the structure of lanthanum niobate. However, upon doping of the niobium site with tungsten, one observes an additional resonance that is very distorted and at a chemical shift of -960 ppm. This corresponds to a niobium site that has a coordination number that is greater than 4, typically 5 or 6. And this actually corresponds to the niobium in the structure that has interstitial nearby. If you'd like to know more about this work, I encourage you to download our paper that was published earlier this year in Chemistry of Materials. Thank you very much for listening.